Okay, so now we're going to look at proportional relationships, how they compare to unit rates. Now, in a proportion, it's a statement that says these two ratios are equal, and the ratios are pretty much written in fraction form. Every now and then you'll see them with the colons or the word to, but usually it's in the fraction form, and it has an equal sign in between them. But we can use this idea of a ratio table or cross products or a tape diagram or unit rates or a double number line or any of those to figure out the answer to a proportion. But before we get to that point, let's take a pretty simple problem. At Cocoa Bean Chocolate Factory, 2 pounds of their world-famous chocolate fudge sells for $1. Now, you're going to notice that that statement about chocolate fudge selling for $1, or that 2 pounds sell for $1, is written and represented right there, because it says that 2 pounds of fudge, which is what's written on the left, those are the units, and $1 is the cost. Now, it then asks us in the problem to use your ratio table below to find the costs of different amounts of fudge. In order to do this, we have to use the relationships that we know. We're going to use this unit rate of 2 pounds for $1. And the way that we know this is a unit rate is because the denominator, if I were to write that as a fraction, that denominator is 1. That's what makes it a unit rate. So in order to figure out what 1 pound of fudge would be, we have to take the amount that we were given, which is the 2, and say, how do you get from 2 to 1? What can we divide 2 by to equal 1? Well, we can divide 2 by 2, because any number divided by itself will be 1. So we took the amount of fudge we had and said, what do I need to divide by? The answer is 2. But we know that, kind of like with fractions, what we do on top, you got to do on bottom. So what we did to the amount of fudge, we have to do the dollars. So we're going to take $1 and we're going to divide it by 2. Now, if we're dividing $1 by 2, we have to say, well, what's $1 divided by 2? Most of us know that to be 50 cents. So we get that 50 cents is how much 1 pound would cost. Now, we can then go and say, well, if I have 3 pounds of fudge, how much would that cost? Well, think, how would I get from 1 to 3? What would I do? Well, I would say 1 times 3, right? So now for that 50 cents, we can say, what's 50 cents times 3? We know that to be $1.50. Now, to get for 4. Hopefully by this point you should have noticed that the pounds of fudge is increasing by 1, 2, 3, 4, and that the cost is increasing by 50 cents. So we can say 50 cents, $1, $1.50, $2. We can also say that, well, if 2 pounds cost $1, to get from 2 pounds to 4 pounds is doubling, so $1 would double to $2. We could say that if 1 pound costs 50 cents, 1 times 4 is 4, 50 cents times 4 is $2. Any of these relationships are fine to use to figure out the amounts. So now we can think about how much fudge can we get for $3? Notice that we've sort of stopped this pattern of increasing by 50 cents. So now we have to use the relationship. Well, if I look at this, I say I can go back to 50 cents and figure out how many 50 cents are in $3. Or I can say, well, I can say $1 times 3 would equal $3. So for the 2, I could say 2 times 3, and 2 times 3 is 6, so I could get 6 pounds of fudge. Again, if we were to do the 50 cents to make 3, we could, which means we'd get 6, and then 1 times 6 is 6. Any of these options, the important part is to figure out a relationship that works and to utilize that. Now, what about $5? Well, for $5, I can say $1 times $5, which means we would then have to take the 2 and multiply it by 5. Or again, you could use 50 cents and say how many 50 cents are in 5. Most of you probably know that there's 10 50 cents in 5. So 10 pounds of fudge for $5. Or you could have said that I know 2 pounds are $1. $1 to get to $5, multiply by 5. So multiply the amount of pounds by 5. Any of those cases. Then for 11, we know that our pattern says, hey, if our pounds go up by 1, that means our amount of money is going to go up by 50 cents. Or we can say, how do you get from 1 to 11? Well, I know I can get 1 to 11 by multiplying by 11, so then 50 cents. times 11. It's all about relationships through multiplication and division. It doesn't matter whether you're using multiplication or division, and notice that we kind of went all over the place with this. So you can go either way, your choice for whichever way works for you. Again, there are multiple answers. Now, if we didn't want to make the whole ratio table, we could actually just use the ratios we were given to calculate the amounts, kind of the way we did up there, in noticing the relationships. So we see that to get from 2, if we were just asked, here's the problem. At Cocoa Bean Chocolate Factory, 2 pounds of their world-famous chocolate fudge sells for $1. How much fudge can you buy for $5? Well, I know that I could say $1 times $5, and then I can just take a really shortcut and say that 2 times 5, and notice that we'll end up back with 10, which is what we got in the original chart, but we didn't have to fill in all that stuff below it. We can just jump straight to that problem. The other way to do it is to go backwards and then use that to work forwards. So we can say that, well, I don't know how to get from 1 to 5, but what I do know is I can get from 2 to 1. 2 divided by 2 is going to equal 1. So I can take $1 and divide it by 2 and get that 50-cent mark. And then I can use that information to say, to get up to 50 cents, what would I do to get to 5? Well, that's 50 cents times 10. So I could take 1 times 10, and I know that I would end up with 10 pounds of fudge. Here are 3 ways that we were able to answer the same question. All 3 of them gave us the same answer. We just approached it a little bit differently. Any of those options are fine to go about when you are solving these. Now, if one ratio is known, the way we knew that 2 pounds were $1, we can use this to calculate missing values for any similar ratios, as long as there's relationships all over the place. And what I mean by relationships all over the place is, I want to take a look at that bottom left chart where it says 2 pounds for $1. Okay, there are 3 different relationships showing here, because it's showing that 2 and 10 have a relationship because they're both talking about fudge. It talks about that $1 and $5 have a relationship, and that's talking about money. So notice that the 2 numbers in the top had the same unit, the 2 numbers in the bottom had the same unit. That's 2 of the relationships. So units play an important part, and that's why I'm writing the units out to the left. Helps organize the thoughts and your numbers a lot better that way. The other relationship is going to be the one that's vertical, that's up and down. The problem tells us 2 pounds cost $1. That tells us that 2 needs to go on one side of the bar, or needs to go on one top or bottom, and that the cost is going to go on the other. When we go to fill in that $5 and think about where does it need to go, since we put $1 in the bottom, we need to make sure that $5 goes in the bottom. I could have put $1 in the top, that would have been fine, and then 2 pounds in the bottom, but it meant that if I put $1 up top, I would need to put $5 up top, because you want to keep those units the same. So your units across for the top should be the same, across for the bottom should be the same, but going up and down, they need to share a relationship, and usually that relationship is going to be given in the problem, or it's going to be a conversion that you just happen to know from memory. Okay? So if 2 ratios are equivalent, their cross products should be equivalent, and that's what we can use cross multiplication to solve the problem. So let's take the same problem. How many pounds of fudge for $5 can we buy for $5 if we can get 2 pounds of fudge for $1? So once again, we're talking about fudge, and we're talking about money. Now, if you are wanting to, I can set this up and I'll show you we'll get the same answer no matter whether we put fudge on top or whether we put money on top. So they told us that we can get 2 pounds for $1. So 2 pounds of fudge for $1. Now that those units are set up for me in the beginning before I even fill in the numbers, it makes it really simple to go and figure out where the numbers should go. For the $5, that's money. That means it's got to go on the bottom. I know that because money is written on the bottom. I wrote the unit for money on the bottom. And then we're going to fill in a variable. So we're looking for how many pounds of fudge. So I'm going to use a P. When we cross multiply, I know that there are lots of fun little mnemonic devices that you have been taught by math teachers in the past, but you will not hear me use them. It's called cross multiply. It's saying we're going to take $1 times p, and 2 times 5. Please take the steps to write out this multiplication. Simplifies life way easier on you, and it's making sure that you don't get confused when you figuring out what to multiply, because there's going to come a time when it is going to be a little more difficult. So $1 times p is going to be 1p, and 2 times $5 is $10, or is 10 pounds, excuse me, 10 pounds. And so we get that we can get 10 pounds, which we knew because we solved it 3 different ways up top. We also could have said, instead of putting fudge on top, we could have come in and we could have put money on top. And I just want you to see that it will work out the same. So we know that we can buy, for $1, we can buy 2 pounds of fudge. And we are then asked about how much for $5. Well, I put money on top this time, so I'm going to put money on top there. And we want to know how many pounds. So we go through the cross multiplication part. And look, we get the same answer. We're cross multiplying the same information. And we get the same answer. So as long as the units are written to the left and the units are the same across the top and the same across the bottom, meaning money is either both money amounts are on top or both money amounts are on bottom, whichever way you do it, you will get the same answer. So that is why units play such an integral part in this. For the cross multiplying part, it's pretty much just multiply the numerator with the opposite denominator and the denominator with the opposite numerator, and then solve the equation like you would any other equation.